I would like for you to set up the model first. Figure out what's constant, what's changing. Draw some pictures. And I'll help you set up the model before we do the calculus stuff. Let me give you 5 minutes to try to set up the model. If you feel confident in your model, you can keep going, but I think the first picture I would draw, maybe the picture looks like this. Oops. This is 10 feet. It's a ladder. And then the next picture, still 10 feet. And then the next picture, still 10 feet. I feel like these 3 pictures kind of model the situation as time passes. The ladder is sliding down the wall like that. Does that make sense to everybody? Any questions? So Michelle, you are correct. This is a right triangle. Let me draw a snapshot photo. In my snapshot photo, maybe it looks like this. And then I want to label the 3 sides. This is a right triangle. Is this side here a constant or a variable? What do you think? Constant or variable? Constant or variable? Variable. Variable. And because it's a horizontal thing, I call it X. What about this side here? Constant or variable? What do you think, Joe? The constant variable of this side? Variable is right. That's right. It's a vertical thing, I call it a Y. Last one. This side, constant or variable? Constant. Good. Constant. So I want you to notice that we're talking about 3 sides of a triangle, and they're not really referencing the angle between them. So let me read this question now more carefully. A 10-foot ladder is leaning against a wall. If the top of the ladder slides down the wall at a rate of 2 feet per second, how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall? So I see a rate here. The rate I see here is 2 feet per second. So I claim that this is related to d something, d something. Does this look more like a dy dt thing or more of a dx dt thing? What do you think? Dy dt or dx dt? Dy dt is correct, Simon. I almost want to put dy dt is equal to 2 feet per second. Why do I say almost? Why don't I just write 2 feet per second? It slides down, so it's negative because wow, it's like you guys are the same person. It slides down, so it's negative because y is getting smaller and smaller. That is exactly right. I'm happy now. I'll show. What else do they say, Tommy? They want to know how fast. Once you see this word, how fast, that means they're looking for a rate. Now, this is a related rates problem, so we're always looking for a rate. But how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall? How do I express this question? It should be d something dt when something is equal to 5 feet. That's what we're looking for. What is it that I'm looking for here? D what dt? Just tell me the letter to write here. Dx dt is right, Leah. And do I want to put an x here or a y here? X is correct as well, Leah. Right, because how far I am from the wall, that's measured by the bottom of the ladder. That's the dx. So this is our setup. Once again, I want to reiterate, we have three sides of a triangle. Two of those sides are changing. One side is constant. There's no mention of the angles between, so it's not a trig relationship. So I think it was Reagan who originally said this is a Pythagorean relationship. Reagan, you want to unmute yourself and tell me how to write down the Pythagorean relationship, please?
Tan equals to square square is it no root square root tan equals to square root of y square plus x squared.
Okay, you said something very wise here, but I don't want to write what you wrote, and I want to explain why. So I was hoping that you were going to say 10 squared is equal to x squared plus y squared. But what you had said was 10 is equal to the square root of x squared plus y squared. And I strongly prefer this to this. And the reason why is when I take the derivative of this side, I'm going to have a chain rule. And that chain rule is going to look ugly. Not too ugly, but you're going to have, this would be like x squared plus y squared to the 1/2 power. So when I take the derivative with respect to t, that would be 1/2 x squared plus y squared to the negative 1/2 times the derivative of the inside, which would be 2x times dx dt plus 2y times dy dt. That's just like ugly. So I actually don't want to involve the square root. So I'm going to delete this. And I'm just going to work with this without the square root, so I don't introduce an unnecessary chain rule. This relates the variables, so maybe I should have put a. This relates the variables. And then the next thing we want to do is we want to relate the rates. How do I relate the rates? I take the derivative of both sides with respect to t. What's the derivative of 10 squared with respect to t? Good. 0. Because it's a constant. All those really lame quiz questions I put on where I put like pi squared, and then you guys are like, oh, the derivative of that is 2 pi. And I'm like, no, it's not. It's just because something looks like an exponent, you got to think of whether it's constant or not, right? So this is constant. Derivative of any constant, 0. The derivative of the right-hand side, we got to use the chain rule or implicit differentiation. It's 2x times dx dt plus 2y times dy dt. I want to isolate the dx dt. So I got to do some algebra. So I'm going to have 2x dx dt is equal to negative 2y dy dt. I simply take this guy and I move it to the other side, and then I flip it around. To isolate the dx dt, I'm going to have dx dt. I'm going to multiply both sides by 1 over 2x. And then I'm going to get negative y over x dy dt. Next, I want to know the rate when x is equal to 5. So I'm going to put dx dt when x is equal to 5. I'm going to get negative y over 5. dy dt, they told me, was negative 2t. Wait, negative 2, sorry. And the units will be feet per second. I have a small issue here. I don't know what y is. Does anybody have any brilliant suggestions for me? How am I going to find y? Just say the magic words.
Use the Pythagoras and
Correct. Simon, correct. Leah, correct. Reagan, correct. We draw a little triangle. It's an ugly triangle, but it's fine. We only have 2 minutes. This side is 10. This side is 5. This side is y. This tells me that y squared is equal to 10 squared minus 5 squared, or y is equal to the square root of 100 minus 25, which is the square root of 75, which, if you're fancy, is 5 rad 3, because you could, maybe I should explain that. That's equal to the square root of 3 times 25. That's equal to 5 times the square root of 3. So our final answer is going to be, oh, the negative times a negative is going to give me a positive. My y was going to be 5 rad 3. We got divided by 5. We got times 2 feet per second. So again, the numerator and the denominator here cancel. And then I end up with 2 rad 3 feet per second as my final answer. When I take a look at this answer, this is positive. Does that make sense to me? It does, because as the ladder slides down the wall, this x length is getting longer and longer, right? So expect a positive derivative. All right, folks, it's been great.